Not only the curious look through this prism. Traditionally, summer is the time for the big road trip, and it turns out that that's not only true for humans. This week, the 1-ton Mars rover Curiosity began its first major journey, heading not to Palm Springs or Daytona, but the foothills of the red planet's own Mount Sharp. Mind you, some people plan their road trips well in advance, maybe even as far as 2020. And with that in mind, riding shotgun with us, or at least someone fueled by curiosity, is John Logsdon, founder of the Elliott School's Space Policy Institute at George Washington University, and also the author of John F. Kennedy and the Race to the Moon. We're also joined by John Mustard, a professor of geological studies at Brown University, who this week led a panel that gave NASA a blueprint of the science objectives of the 2020 rover and mission to Mars. Welcome, gentlemen.
Good afternoon.
Good afternoon. Thank you.
Dr. Logsdon, just about 11 months ago, Curiosity landed. What have we discovered, and how well has it been performing?
Well, it's been performing excellently. It's a remarkable achievement to land a 1-ton vehicle with precision on the surface of Mars and then have all of its instruments working. It has confirmed what it was sent to discover, which is that Mars could have been habitable. The conditions for habitability, that is, the existence of life, exist where Curiosity landed, where it's done its initial exploration, and now it's headed towards its ultimate target, which is, as you say, the foothills of Mount Sharp, where there's kind of a sedimentary rock that should give a good sense of the evolution of habitable environments on Mars.
And Dr. Mustard, Dr. Logsdon said that Curiosity has made some interesting finds. What are some of the most exciting ones, and has there really been evidence that there may have been life there in some microbial or other fashion?
That's an excellent question. I'll perhaps go to that because I think Dr. Logsdon specified that the identification that Mars was once habitable had the right conditions of aqueous chemistry and a clement conditions for microbial life was demonstrated with Curiosity. Did it detect evidence of there having been current or past life? Absolutely not, within the measurements that it's made to date. And in fact, MSL doesn't have that capability to give it definitive evidence of there having been past life. It has the capability of showing there may have been signs of that through their organic compounds that may have been left there.
And Dr. Logsdon, just following up on the life question, then we'll come back to Curiosity. There's been an ongoing debate for years, possibly decades, about where life on Earth and other planets possibly may have come from. Some people believe that the materials necessary for life came from comets or asteroids that impacted the Earth. If that's the case, why wouldn't there possibly been similar strikes on Mars or other planets?
Well, there could have been. Most of the other planets in our solar system are not very congenial for the existence, the continuation of life. So if the organic compounds had come in on a comet, it's not clear that they could have survived. But Mars is a little different. There is this concept called panspermia that says life can be spread many places through this process. And Mars is one of those places. Whether it evolved on Mars in the way it evolved on Earth is very unlikely. But it's hard to say the odds. But it is reasonable to speculate that there could have been past microbial life on Mars.
Now, moving away from life for the moment, Dr. Mustard, both of you seem fairly excited about the prospects of exploring Mount Sharp. Why is Mount Sharp so important, and why are we sending Curiosity there?
Mount Sharp is an exceptional target. Why is it so exceptional? Because it has beautifully organized layered stratigraphy, or layers of rock, which are changing in their composition as you go up the hill slope. And to a geologist, that is just perfect. That's like reading the record. As you walk up the hill slope, you're going up in time. You're becoming younger and younger. And so you can actually decipher when and how various conditions on Mars had changed. And why is this exciting? Because the base of Mount Sharp has a collection of minerals, which are clay minerals, which, from our understanding of terrestrial systems, are often indicative of clement conditions for microbial life. And clays are actually very good at capturing and hanging on to organic compounds. As you go further up section at Mount Sharp, the rocks change to become more rich in sulfur and sulfate compounds, and that tends to tell us it's become less hospitable, although not completely inhospitable to life.
And following up on that, so basically what's exciting about that is that we're able to see the rings of a tree in this mountainous form on Mount Sharp, and so we're able to get so much more information about how it evolved geologically. But are we really getting more than we were able to see through the HiRISE telescope by driving through this?
Oh, sure. I mean, you have a much different set of instruments. You can actually sample the materials. You can do chemical analysis of it. So there's really nothing to substitute for being there, ultimately with humans, by the way, to do a full job of exploration.
Dr. Mustard, as good as the quality of the images and data that has been sent back by Curiosity has been, and it's been amazing from the things that I've been able to see, how do we need to upgrade it when we're looking at the next set of rovers?
So one of the things that you might imagine, I think Dr. Langston brought that forward, is that the type of measurement you can make on the ground is an order of magnitude better than you can do from orbit to answer questions about how that planet has evolved and the prospects of perhaps having preserved evidence of there being life. In order to do that to a level of scrutiny and certainty that would be convincing to the community of skeptics, because scientists and in general are skeptical about what others have claimed to have found, those samples need to be brought back to Earth. You've got to have those samples in a Earth laboratory with the big machines. And that, to us, we just finished the science definition team report for NASA to say what the science goals might be for the rover in 2020. And one of our top recommendations is that rover have the capability of selecting samples to be put into a cache for return at a future date. That is exceptional should NASA go ahead with it, because it really lays the groundwork to address the question of were there inhabitants of some sort on Mars in the past.
There's something you said there which really strikes my mind. One of the problems with Curiosity, which is being solved by making it more autonomous, is the lag time it takes to send a signal from Earth to Mars. I understand that can take as long as maybe 20 minutes. So is one of the things we want in the next generation of rovers is not even necessarily better sensors and better ways to analyze the material, but just better artificial intelligence?
Well, I mean, you can't overcome the laws of physics, so it's going to take 20 minutes at the speed of light, at 186,000 miles a second, for a command to travel from Earth to Mars. What is being planned for the next rover, that Dr. Mustard's team has recommended, is a set of instruments that can do biological characterization, which Curiosity cannot do, and do it in a very intelligent way, select samples, package them, and then leave them for a future mission to bring back to Earth.
And probably I'm going to ask the same question of both of you, but let's start with you, Dr. Logsdon. If you could take control of the joystick, what would you have Curiosity do, and what is the question you really want to explore?
Well, with Curiosity, you cannot answer the question, was there life? You can answer the question, were the conditions for life very favorable? So I would go where Curiosity is going, because that's the place that it's most likely to provide the answer to that question.
And Dr. Mustard?
What would I do if I could? Actually, I wouldn't get the joystick. I'd just hop in the seat, start put the pedal to the metal. And I would definitely go to the base of Mount Sharp and start digging right away, and really want to look at the texture of the rocks, and I'd want to smell the rocks because I can usually tell if it's been contaminated by some sort of biology based on the aromas. And, a geologist often, one of the best tools they have is to lick the rocks because you're able to kind of see the textures better. So, if I could actually be there and do that kind of work, that's what I'd do. And that would be an exceptional experience.
Now, it sounds like somewhat of a flip answer, but I've spoken with other people in the field, and they say there needs to be a place still for human exploration, whether we're talking about asteroids or Mars or other, because there are certain questions that a robot or a rover just can't perform. Do you agree with that?
Well, you just heard Dr. Mustard say he wants to go. I mean, he's a field geologist, and field geologists are much happier in the field, and if that field happens to be Mars, they would be ecstatic.
And Dr. Mustard, should we be sending you?
Well, I could be, but the journey's kind of long for me at the moment. Maybe my son could go. But the humans are, as an explorer, humans are exceptional. And they can do things that no rover that we've currently made could possibly reproduce. And in terms of just the sheer drama and excitement of having a human walking on another planet would pay for itself right there. And I think we should be definitely considering sending humans to Mars.
I want to move to philosophy for one moment. I was speaking to some people about a year ago at the Air and Space Museum at Smithsonian, and they said that in their belief, today we would not be able to send a man to moon. And it wasn't because we didn't have the technological ability to do so. It wasn't because we didn't have the resources to do so. But it was because they thought that we lacked the will necessary to mobilize all those resources. When it comes to Mars, clearly we still have the will to mobilize enough energy to send a rover. Do we have the willpower? Do we have the public enthusiasm necessary to get humans to Mars? And if we don't, what could we do? What should we be sharing that Curiosity, the High Rise, and other things are discovering that might ignite that fuse?
Well, first of all, you have to define who is we. I don't think sending astronauts to the moon was a Cold War competition with the Soviet Union. It was literally a race. There's no reason to race now, and there's no reason that it should be only the United States. This really must be a global effort, both philosophically and to make it affordable. So I think we have to engage the spacefaring countries of the world and others in preparing for this adventure and getting engaged in the robotic exploration and make it an enterprise of the globe, not of one or two countries.
It sounds a little bit like Gene Roddenberry in Star Trek in philosophy, but do you agree, Dr. Mustard?
Perhaps. I mean, I think the humans are explorers, and to address some of the most important goals and objectives of humankind is to explore a planet such as Mars, because it is so compelling as an Earth-like object that has, to me, it's kind of like a Star Trek episode to go to Mars, because it's kind of familiar, right? I mean, everything looks the same, but when you dig a little deeper under the surface, it's totally different. Why is that? And how different is it, and how do I go about exploring that? Humans are the vehicle by which we could have a grand adventure to understand that.
And come back and talk about it.
And absolutely, you want to come back. There's definitely a cohort within our community and on Earth who would volunteer for the one-way trip to Mars, but I think it absolutely has to be a round trip.
And we're coming on a little bit more than 40 years past landing on the moon, and we can now say what the legacy of that was in terms of inventions and innovation and knowledge. 40 years from now, 50 years from now, 100 years from now, will we view the landing of Curiosity as a truly significant moment?
Well, I think it's a step in a path, and the path, I think, leads to sending the first explorers to Mars, making the decision on whether we want to stay there for longer periods of time. We may not. So 100 years from now, we may have people being born, live, and die on Mars. And Curiosity will be an important step along that way.
The future will tell the tale whether or not this is the most significant moment that we think it is. Curiosity was able to land a ton on the surface, and that ton was in the running position, ready to take off. Right, that was an exceptional engineering talent. What the next steps will be is not necessarily just to replicate that, but to land the mass that would contain humans, for example, and then indeed Curiosity would be that signature moment in engineering and development that paved the way.
Looking down the path of Curiosity and maybe following it. I'm Andrew Hiller for The Prism, and I've been joined by Dr. John Logsdon. He's the founder of the Elliott School Space Policy Institute at George Washington University, and Dr. John Mustard. He's a professor of geological studies at Brown University. Thank you, gentlemen.
Thank you.
Thank you.